Okay. Uh, Gaussian process. So previously we saw ergodic process. So ergodic process, um, it will be you know the collection of total entire process. So it will be show that bad eye view of that entire process, that is called as ergodic process. In ergodic process, um, that so many for example number of transistor or number of anything. So number of transistor we can draw number of waveform. So in that waveform we just take it as average time period, we plot that one single waveform, and finally that will be represented for the entire process, that is called as ergodic process. In Gaussian process, so it is also stochastic process. What is stochastic? I already said Doraemon process. So collection of random variables indexed by time or space. So that is called as Gaussian process. So Gaussian process is a collection of a random variable indexed by time or space. That is called as Gaussian process. So Gaussian process name because of Carl Friedrich Gauss. So he found that Gaussian process. So from his name, the name came that Gaussian process. So Gaussian process can be seen as an infinite dimensional generalization of multivariate normal distributions. So Gaussian process also useful statistical modeling, and then that random process models are Gaussian process. Then distribution of various derived quantity can be obtained in explicitly of the Gaussian process. Then so Gaussian process is a lazy learning, and it measure the similarity between points. Gaussian process is measure of similarity between points, that might be a kernel function, to predict the value of unseen points. So that is Gaussian process. So Gaussian process will be predict the value of unseen points. Also, it will be measure the similarity between points. So that's the usage of Gaussian process. Okay, so it's a definition, a time continuing stochastic process. So if the Gaussian having if the equation might be x t1, t1 is the time period, x t1 up to tk means fixed time period. So we can write as capital X, x of t1 and up to that capital X of tk, the multivariate Gaussian random variables. That's also written in equation, e of exponential of I summation of 1 to k. So st x of tl, then exponential of minus 1 by 2 summation of lj sigma of tj 8l. So the equation is continuing like that, where I donate the imaginary units such that I square is equal to I1. So that's a formula we already know, I square is equal to minus I1. So number of sigma and j and mu, it can be shown that covariance and mean of the variables of the process. So the numbers of sigma and j and mu, so these are shown the covariance and the mean of the variables in the process. So variance. So variance of Gaussian process, it's a formula, the variance of Gaussian process. So previously we saw mean and covariance of Gaussian process. Now variance of Gaussian process, the equation is x of t equal to E of x of t minus E of x of t whole the power, that means square of that less than infinite. So this is the equation for variance of Gaussian process. And stationary of Gaussian process. So stationary, we know that's a stochastic process. Fixed and stationary, wide and stationary. So these are the same. Uh, However, the Gaussian stochastic process is a two concepts are equivalent. What two concepts are equivalent? A Gaussian stochastic process is stationary. Even the wide and stationary, both concepts are equivalent. The Gaussian stochastic process, strict and stationary and wide and stationary, both concepts are equivalent. Example, the representation of Gaussian process equal to x of t equal to cos a t psi 1 plus sin a t psi 2, where psi 1 and psi 2 are independent random variable with the standard normal distribution. So this is an example for Gaussian process. So it's a independent random variable with the standard normal distribution. Okay, so Gaussian process is a stochastic process. It's a collection of random variable indexed by time or space. So this is the main definition. So previously we saw from ergodic process, it's a taking n number of sample, n number of graph, and finally we take it from statistical property. In Gaussian process, we have to measure similarity between points. That means we have to predict some unseen points. So based on that, we have to find the average of the mean and covariance and stationary and auto covariance. So everything get it from. So what is mean, what is covariance, you already know. Mean means it's related, it's deal with only one signal. Covariance and auto covariance are related with the deals with two signals. So mean also it's average of one signal. That means one function or one operation or one parameter, whatever it may be. And similarly, it's a relation of two signal. You will be get the average between these two signal information, get it from two signal, that is called as covariance, auto covariance. Like the stationary process, even the probability distribution won't be change even the time is shifting. Even the time is shifted, the probability distribution won't be changed. Okay. Okay. Thank you.